y and the corresponding value of x and y and the probability of x and y. So according to the above table, you first have to calculate covariance, right? And then you have to find out raw xy. And then the third one is the conditional expectation, okay, when y is equal to 20. And the fourth one is the conditional variance of x when y is equal to 20. And then this is the function of random variable, okay? So of course when you calculate covariance, you're going to get expectation of x, variance of x, and expectation of y, variance of y. And then from there you can get expectation of 2x plus 2y. And that is basically expectation of 2 times mu x plus 2 times mu y. And the third one, that is 2x minus 2y, okay? So generally, when x, y are independent, that will be easy. But here, x and y may not be independent. So you have to calculate, okay, in this case, variance of 2x minus 2y going to be 4 times vx plus 4 times vy minus 8 times covariance xy. Okay, let us move on. Let us look at the answer. Of course, expectation of x is equal to summation x times px, right? So the formula there tell you that expectation of x should be equal to 20, and then expectation of y should be equal to 40, and expectation of x squared, okay? So in this case, you use this one, and then what is variance of x? Variance of x is equal to expectation x squared minus mu x squared, okay? So basically from there you can get expectation of x and expectation of y, and here that is variance of x, and here variance of y. And then you get covariance of xy, that is expectation xy minus expectation of x times expectation of y. So basically, if you apply the formula, you should be able to get it. So basically, when I have this question, I suppose everyone should be able to get it. And indeed, most people get this right. But some of you may have made some mistake in terms of your calculation. Okay, so just try to be very careful. You should be able to get this kind of question. Okay, any question so far? And I suppose on your exams, the teaching assistants already put down the correct answer onto your exam. So, but in any case, if you need to get what's the correct answer, it is also here. Okay, questions? No? Okay, let's get to the next one. Here, that is raw xy, right? If you're going to get raw xy, you have to divide it by sigma x and sigma y, okay? So basically that is there. And when you do the conditional expectation and conditional variance, of course you need to use conditional probability, okay? So here, this part, it is conditional probability, and here. And because if you look at this, okay, one of the conditional probability is equal to 0. What does that mean? Are x, y independent? Of course not, right? Because if they are mutually exclusive at some point, that means that they cannot be independent, okay? And then here, okay, basically this question, it is 2 times mu x, 2 times mu y, and here you have 4 times variance of x, 4 times variance of y, and minus 8 times covariance xy. Okay, any questions? So basically, you just apply the formula and you should be able to get it. And also, before the exam, when we done the final review, okay, for the midterm, we have shown some questions like this too. Okay. Okay, and here you have whole bunches of number. You have, I think it is 13 number. Is that right? Okay, and you're gonna get medium. Okay, but be very careful, because when you want to get medium, how to get that? You have to sort the data first. Okay, you have to sort the data first. And basically the same thing. You just apply the formula, you should be able to get it. Okay? So here you have to rearrange the data, okay, in terms of, in this case, it is ascending order. Ascending order, it means that it is higher and higher. When we say descending order, that means it is lower and lower. Okay, so here it is ascending order. And you have medium is 9, and the mode, of course, is 9 here. And then the average, you just add all the number and divide it by, you know, the total number we have. We have 13 numbers. And then here you get variance, okay? You get variance, okay? Basically, we apply the formula. It is xi minus mu x squared, okay? And then you get variance, and if you want to get standard deviation, how you going to get that? You have to take square root of it, okay? You have to take square root of it. And here, that's the answer. You know, in this exam, some people, for example, here we should have 15.60688, but some people only put down 16. Okay, some people put down 16. This is not a good answer. Okay, and basically, when you calculate this number, okay, you should just take the whole thing down. Okay, you don't round up. Okay, round up means, you know, when it is like here, if you round it up, then you have 16. Because it really takes you no cost, okay? It costs you nothing to get all these numbers. So in the second midterm, please take down all the number you have when you get the result, when you hit the calculator, okay? You need to give me all the number, okay? You don't do any round up here. And then here you have square root of it, so this is the answer. Okay? Generally, I would expect you at least give me 4 decimal points here. You give me 4 numbers after the decimal point. Okay? Give me at least 4 numbers. Okay, so this is one of the, one of you rounded up too early. Okay, so 15.6, but give me like 16. That is not good. Okay? Anyway. I think I only take 2 points off. Supposedly, you know, one question it should be 5 points, right? But I only take 2 points off. Okay, now this is another question. So we have a product, and the product is a steel bar, okay? And some of them may be, you know, defective, some of them not. So the defective rate, okay, for A company, that is 0.85. And for B, that is 0.75. And so if a batch of steel bars, you know, consists of 40% from A and 60% from B, of course, you know that when you select anyone that is defective, you know, you want to know, because part of it can be from A and part of it can be from B. And also, you know, the probability of the defective rate. So you have to consider all this. So the question is, if randomly choose, it should be any steel bar. There is if randomly choose any steel bar from that batch, what is the probability that it will become rusty in 3 months? Okay, so this is from A, okay, and this is from B, okay, the defective rate. And how many gonna be from A? 40%. And how many gonna be from B? 60%. So you calculate this, then you should be able to get it. Okay, and here that is the Bayes theorem, right? Bayes theorem, or we say, you know, conditional probability. Okay, so basically it should be another easy question. Okay, so probability of A given B, it is probability of A and B given B. Okay, I mean given the probability. I think what's going on here? So I think I mistook it somewhere. Anyway, so I mean you get the idea, okay? You get the idea. It is just somewhere, but just not at this PowerPoint file. Anyway, it should be somewhere. Okay. Do we need to calculate it? Okay, so let us do it. Here, so you have from A, okay, the rusty rate is equal to 0.85, right? And, you know, we have 40% from A. And then from B, the rusty rate is 0.75, okay? And 60% gonna be from B. Okay, so if you choose anyone from this batch, okay, and what's the percentage it's gonna be rusty in 3 months? So that would be 0.85 times 0.4 plus 0.75 times 0.6. Okay, and so you can get a number here. Okay, you can get a number. Okay, and here the second one is, you know, the Bayes theorem. Okay, so if a rusty bar is chosen, what is the probability that it's going to be from A, right? So then you have the whole thing here. So let us assume this number is equal to X. Okay, so let us assume this number is equal to X. Okay, and then this number going to be from A, right? Here is part of A, so that is 0.85 times 0.4. Okay, so this is the answer. And if you got calculator, you should be able to get it. Okay. Okay, so you know, I don't know, getting more and more absent-minded. You know, sometimes I put a whole thing down, but still something missing here. Okay. Okay, so let us look at question. You know, what is the ratio of the people to take computer only? So as a matter of fact, you have 3 parts, right? So you have 3 courses: computer, English, and finance. Okay? There's a typo. Typo, right? Anyway, so there's a typo here. So, you know, we have survey. So 40% going to take computer, 30% going to take English, and 20% going to take finance. Okay, so let us put it down here. Let me see if I have... So here you have computer, right? Computer 40%, English 30%, and here it is the finance 20%. Okay, and also you have, you know, some people take 2 courses, and also there's some people taking 3 of them. Okay, so here is the formula for what's going on in terms of the question. So you have PC equal 0.4, PE equal to 0.3, and PF equal to 0.2, and etc. And of course, the first one, okay, what's the first question? The first question, what is the ratio of the people? No, the first question is, what's the ratio of the people to take at least 1 course? Okay, for them to take at least 1 course, that means, okay, probability of A or B or C, right? So here you calculate probability of A or B or C. And so you have probability of A plus probability B plus probability of C minus probability A and B, B and C, and A and C, and then plus probability of A and B and C. So here is the answer. Okay? And the second question, what's the ratio of the people to take computer only? Okay, so from here, you know, computer only. So you need to get computer science here, right? And you have to subtract what? Subtract the one that, you know, takes computer, okay, and something else. Okay, so here, basically, let me show you in terms of this diagram here. So in any case, so let us say this is the set For the people taking computer, right? Computer only is here. Okay, for the people take computer only, it is here. So you have to subtract this one. You have to get rid of this one and get rid of this one. Get rid of these three parts, and here is what you get. Okay, so basically the calculation there is like that. Okay, and then the last question. Okay, so if a computer takes at least one course, and what's the probability that he will take computer? So here, basically, you are required to get this area, and also this area, and also this area. And of course, these three parts, okay, is the probability you are looking at. So you are already told that these people take only one course. But what's the probability that this person takes computer? So it is this ratio, okay, this ratio divided by this one plus this one and plus this one. Okay? So basically that is like that. Okay? Questions? Any question? So for this question, so you have probability for x. When it is equal to 1, it is equal to c. When it is 2, 0.2 c. When it is 3, 0.125 c. When it is equal to 4, 0.675 c. Okay. For this question, it happened. Okay, it showed up. I mean, many graduate school, they have. I mean, there are many this type of question in the graduate school entrance examination. So this is quite typical. So first you are required to calculate C. The only thing you need to know is the probability. Okay, the properties of probability. The properties of probability is that for any event, the probability is greater than or equal to 0 and less than or equal to 1. And for the whole summation, what should be that? It should be equal to 1. Okay, so basically that's what you're going to use there. So here, C plus 0.2 C, etc., it has to be equal to 1. Okay, and because the whole thing it is equal to 2C. Okay, so then what you get? You get C is equal to 0.5. And then you should be, since you have the information about C, so you should have information about X and PX, okay, and variance of X and expectation of X. So because of that, you can apply the formula there. So expectation of Y is equal to expectation 3x plus 2, and then here it is the expectation, so you can get expectation Y is equal to that number. Okay? Okay, the last one. So this is a group data. Okay, it is a group data. And so you have the score there, and also you have frequency. And so what's the point? What's the value to represent for the people in this group? It should be 34.5, right? And here that's 44.5 and 54.5, etc. Okay? And basically you apply the formula summation of xi times RFI. RFI is the relative frequency, right? Relative frequency. So basically that is like that. Okay? 34.5 and all these things, okay, and the number is 20. Okay, the total number is 20, so you get the average score, the mean is equal to 68, and then you apply the variance. Okay, basically that's just apply the formula, plug in the numbers. You should have no difficulty there. And because now you are required to get standard deviation, so that is the square root of variance. So this is what you get. Okay? Any questions? Let us take a break. To the discrete random variables. As a matter of fact, there are many types of discrete random variables, and we want to discuss some of the most important ones. So the first one we're going to discuss is the uniform distribution. Okay? So for Ms. Wang, please concentrate on this class at this point. Okay, so we have uniform distribution. So x, the value of x can be from 1, 2 to n. Okay, so then what does that mean? The probability of x. So here we use fx equal to x. Here actually that is the probability. Because you have n numbers, so for the probability of each number to show up, that is 1 over n. Okay, 1 over n. And so the same thing, you are required to calculate expectation. So what is the expectation? Expectation of x is equal to summation x times px. And in this case, we use fx. So expectation of x is going to be summation of x times fx. And what is that equal to? 1 over n times bracket 1 plus 2 plus 3 up to n. So then that is 1 over n times, okay, what is the sum of 1, 2, 3, 4 up to n? So that is actually n times n plus 1 divided by 2. So then what you get? So here, there is something wrong here. There should be a bracket, okay? There should be a bracket here, okay? So it is here. So expectation of x is equal to m plus 1 divided by 2, okay? M plus 1 divided by 2, okay? And so the next will be variance, right? After we get expectation, that is the mean, and then we get the variance. Any questions so far? Sorry, there's a mistake here, okay? There's a typo. So this kind of mistake we call typo. Typo, T-Y-P-O, actually it is typographical error. That is we call typo. Okay, question. Variance. Okay, how to get variance? You know, it should be here, it should be expectation, another typo, okay? It should be expectation x squared, okay? It should be expectation x squared. And here, expectation x squared is equal to summation x squared times fx, okay? So finally, we can get all these, okay? Oh, you know, what's missing here? So variance of x is equal to this one minus mu x squared, right? So so it should be a term missing here, minus here, okay? Minus mu x squared. And so here you have 1 over n, 1 squared plus 2 squared plus etc. to n squared. And what is the sum for all these? The sum for all these, it is n times n plus 1 times 2n plus 1 divided by 6. And here you have 1 over n minus, okay, because here you have n plus 1 divided by 2 to 2's power. So you have here n plus 1 squared divided by 4. And then for these two terms, okay, for these two terms, I'll give you 10 seconds to take it down, okay? Make sure that, okay, put minus mu x squared here. So there is a term missing, minus mu x squared. And then, of course, you know, here you should have a bracket, okay? You have a bracket here. You should have a bracket here, okay? You should have a bracket there. Okay, you should have a bracket before 4, okay? And there's a bracket after 3, okay? A bracket before 4 and a bracket after 3. And so basically what you get, the variance is equal to n squared minus 1 divided by 12. So for uniform distribution, okay, for uniform distribution, the mean is n plus 1 divided by 2. Okay, the mean is n plus 1 divided by 2. And the variance is n squared minus 1 divided by 12. Okay, n squared minus 1 divided by 12. So basically, it is quite easy. Okay, apply the formula we have, and for this kind of specific distribution, you can get the uniform distribution. You can get the expectation, and also you can get the variance. Okay, any questions so far? Anyone needs more time to take the whole thing down? If you need more time, raise your hand. Okay. Sorry, a typo here, you have to put down minus mu x squared, right? Because if you have only this, that is expectation x squared. And also, you have a bracket here and another bracket here, okay? Okay, questions? Questions? Okay, let's move on. Now we're going to get binomial distribution. Okay, what means bi? Bi, in your bicycle, you have two wheels. Bi means two terms. Nominal, okay, it means name. And here you have binomial with two terms. So this kind of experiment, okay, this kind of distribution, it includes the following properties. The first one, the sample space of this random experiment has two possibilities. So bi, okay, bi, bi. Two possibilities, success or failure, okay, success or failure. So before we talk about binomial, actually we have a lot of examples. For example, cast a coin. Cast a coin, you only have two sides, right? Heads or tails, right? Heads or tails. And also, we talk about products. Remember, we just discussed a question, a product. It can be defective, it can be good. That is also two possibilities, okay? So, either way, heads or tail, okay, 0 or 1, or, good or defective, okay? Either way, there's only two possibilities. And now, you are required to repeat the experiment n times, okay? So you are doing this kind of experiment, it has only two possibilities, success or failure, and you repeat it n times, okay? Only two possibilities, success or failure, okay? And the probability of getting success or failure does not change. For example, you cast a coin, right? You cast a coin, no matter how many times you cast a coin, what's the probability you're going to get F, okay? Get heads or get tail. It is 0.5. So that means the probability to get success or get failure, that is the same, okay? No matter how many times you repeat the experiment, the probability of success or failure does not change. Okay. And also, each experiment is independent. Okay, this is very important. So for example, yesterday we got a lottery, right? Okay, lottery for yesterday, I think there's 48 numbers. Is that right? I think it is 48 numbers. Today there's another lottery, right? But it has 42 numbers. Okay. So let me ask you this question. If you take one out, okay, if you take one number out, what is the probability to get the next number? Whatever number it is. It is, so the first one is 1 over 42, right? What about the second one? It is 1 over 41. What about the third one? 1 over 30, because there are 40 balls remaining, right? So in this case, does this satisfy the second criterion? Does it satisfy the second criterion? It does not, because it requires that the probability of getting S or F does not change, right? So let us say the number has been chosen, that is a success, right? What about the first number? It is 42, 1 over 42. The second one, 1 over 41. Is the probability the same? No, right? But if we take it with replacement, okay, what does that mean? So for the lottery we talk about, it is drawing, okay, drawing without replacement. Okay, so what does that mean? If we take it out, do we put it in again? No, we don't. So that is what we call drawing without replacement. But suppose we say after we take it out, we also get it back, right? Then what's the probability to get the next one? The same thing, 1 over 42, right? But for the lottery, it does not satisfy this one, and so it is not a binomial distribution. Okay, and generally, so let us say, for human beings, we generally say 50% male, 50% female, right? But of course, I mean, it is not quite the way we want to talk about it, because the probability to get a male or female sounds like 1/2, but actually it is not. So let us stick to coin. Okay, coin. No matter how many times you cast a coin, the same thing, heads or tail, the probability is equal to 0.5. Okay, but some of the numbers, okay, if you take it with replacement, so what does that mean? Take it, or we say drawing. Drawing with replacement means when you take it out, you put it back again. So if it is a drawing with replacement, then that will be close to binomial. So for example, the lottery we have, it is not, because we take it out, we don't put it back. Okay? Okay, the next one. So basically this is what we call binomial distribution. And that is, you have experiment n times. Okay, you have experiment n times. But suppose you have you do the experiment only one time. If you do this kind of experiment only one time, we call Bernoulli. Okay, Bernoulli, B-E-R-N-O-U-L-L-I. So we call Bernoulli. If you do it only once, if this kind of experiment you do it only once, that is what we call Bernoulli trial. Okay, Bernoulli trial. But if you do it n times, that is binomial. Okay, so let's get to the next question. So now we cast the coin n times. S is for getting head, and F is for getting tail. So for this kind of experiment, only two possibilities, right? Getting F or getting S. Okay, success or failure, and only two possibilities. And the probability of getting head and tail does not change, always 0.5. And each experiment is independent. Okay, each experiment is independent. Next. Okay. So now we have 10 balls. Okay, we have 10 balls. We have 5 red one, 4 black one. So the first question. Sorry, another typo. I mean, this should be 1 something, right? 5 red ball and 4 black balls should be a different color. Okay, anyway. So drawing with replacement, okay? You have to be very careful here. Drawing with replacement. What does that mean? There are 10 balls here, right? When we take one out, how many remaining there? 9, right? But we put it back. This is what we call drawing with replacement. When we take it out, we put it back again. Okay? So what's the probability that the second one is red? Because you put it back again, right? Okay, so what's the probability you're going to get a red one? 5 red one, right? So 5 over 10. Okay, because you put it back again. So the total is still 10. Okay, the total is still 10. So what's the probability is the second one going to be red? The same thing. Okay, 5 over 10. And drawing with replacement, the first one is red. What is the probability that the second one is red? Because what's this kind of probability? Actually, it is what we call conditional probability, right? This is a conditional probability. So given that the first one is red, okay, what is the probability the second one is red? And because we say this is a drawing with replacement, so we take it out, we put it back again. So this kind of trial, what does that mean? Each experiment is independent. Okay, so given the first one is red or any other kind of color, right? What's the probability the second one going to be red? The same thing. Okay, because we say if two things are independent, okay, so if two events are independent, probability of A given B, if these two are independent, what does that mean? You're going to get that is equal to PA, right? So probability for the first red, okay? The second red, we're going to get the second red one, and here is the first one is red. What should that be? That should be the second one that is red. Okay? What I want to emphasize here is that because this kind of experiment, they are independent. Okay? Each experiment is independent. So it doesn't matter the first one is any kind of color. Okay? Whatever color it may be. What about the probability of the second one? It is independent. So it should be equal to probability of second red. Okay? The second one is red. Okay? Is the probability of red. So that is 5/10. Okay? That's 5/10. Okay. Let us move on. So it should be also 5/10. Okay? So each experiment is independent, right? Okay. Sorry, it should be independent. Okay, another typo. It should be independent. Anyway. So 5 is 5 red one, right? So anyway, forget about it. What I said is right, but what I put down is wrong. Okay, it's 5/10. Okay, 5/10. You know, I just don't have enough time to check all the typos there, and too many things. Anyway, now we are looking at a different kind of question. Okay, the first one we only have 10 balls, right? Only have 10. What about here? We have 100,000. Okay, we have 100,000 balls, 60,000 black ones, and 40,000 red ones, and drawing without replacement. Okay, so drawing without replacement, what does that mean? So let us say we have a total of 100,000. What's the probability I'm going to get a red one? Okay, so let us stick to red one. What's the probability the first one is red? Okay, Mr. Zheng. What's the probability the first one is red? $40,000 divided by 100,000, right? Okay. So let me ask you this question. What's the probability the second one is red? Okay, Mr. Wu. What is the you just tell me how to calculate it, that's enough. You don't need to give me the answer. The first question is, what's the probability the first one is red, right? Now the question is, the second question is, what's the probability the second one is red? We are talking about the second one is red, okay? So we are talking about the second one, right? But what about the first one? So the first one can be red, and then the second one is red, okay? And the first one can be black, and the second one is red. So you have these two kinds of probability, right? Because you do it twice, you are looking at the second one, right? So the first one may be red or black, right? The first one may be red or black, but the second one has to be red, okay? So here in this case, what is the probability the second one is red? So here, this is the first one is red, okay? And the second one is red, okay? Here it is the first one is black, but the second one is red, okay? So then here you get the probability here, okay? It sounds like it does not change, okay? But you want to be very careful here, because here in this case we are talking about drawing without replacement, okay? Drawing without replacement. So drawing without replacement, what does that mean? Each experiment is not, okay, is not independent, okay? Because what's the probability you're gonna get the second one depend on the first one, okay? So this is very important here. But there is another important thing here. So when the number of balls is very large, drawing without replacement can be treated as drawing with replacement. What does that mean? Because the number is just too many. Okay, the number is just too big. So you don't have to worry about it. So let us say if you have 1 million bolts. Okay, if you have 1 million bolts. If you take one out, how many left? It's 999,999, right? So the number is still very large. So when the population or the ball is very large, it doesn't matter whether you draw it with or without replacement. Okay? So this is very important here. Questions? Questions? Sounds like confused. We're going to continue for a few more minutes and then take a little break. Okay? Questions? Okay, so here there are two things. We first talk about Bernoulli trial, the second one binomial trial, and then we talk about drawing with replacement and drawing without replacement. Of course you know that drawing with replacement is different from drawing without replacement. But when the number is very large like here, drawing with replacement is the same thing as drawing without replacement. Okay? So now we are going to get to the distribution of binomial, okay, the binomial distribution. We want to get to the mean, okay, the mean and also the variance. So here again, we're going to cast a coin twice, and when heads show up, it is counted as S, so that is a success. When heads show up, it is a success, and tails show up, it is a failure. And X is the number of success, okay, and X is number of success. And now we have probability of X is equal to S, that is equal to P. And the probability of X is equal to F, that is equal to Q. So can anyone tell me what is the relationship between P and Q? So the next person in brown t-shirt. So what is the relationship between P and Q? So we have this kind of experiment, right? There's only two possibilities, success or failure. When X is equal to success, that is equal to P. When X is equal to failure, that is equal to Q. So what should be the relationship between P and Q? What's the relationship between P and Q? Because there's only two possibilities, right? First, P must be greater than or equal to 0, Q must be greater than or equal to 0, and both must be less than or equal to 1, right? Okay? And what about the other relations? Because you only have success or failure, right? So what should be the relationship between P and Q? Miss Wang, what should be the relationship between P and Q? Because you only have two possibilities, right? You only have two outcomes. So P plus Q must be equal to 1. Okay? P plus Q must be equal to 1. Some of the entrance examinations for graduate school, it is so simple. You only need to know this. Okay, P plus Q is equal to 1, and then you can solve for the equations. Okay, but first you need to know the relationship, right? Okay. Okay. So because we say success or failure, and with that X is the number of success, right? If you have experiment only one time, okay, if the experiment is only one time, so you have P x equal to 1, that is equal to P, right? And P x equal to 0. So here that is success, this is failure, okay? Success, failure. So this is the experiment only one time, okay? So you have this, and here you have P plus Q to 1's power, okay? So because you only have P and you have Q. Now you do the experiment 2 times, okay? You will do the experiment 2 times. So what's the probability that x is equal to 2? So you have 2 successes, right? You have 2 successes. So that is P squared, okay? P squared. And if you have x equal to 1, okay, if you have x equal to 1, what does that mean? You have head, tail, tail, head, okay? So it is p times q and q times p, right? And so here it is failure. You have two tails, and the probability is equal to q squared, okay? Probability is equal to q squared. And now you're going to find out something quite interesting, okay? Something quite interesting. What is that? So you have x equal to 1, you have p and q, right? And if you expand this term to 1's power, what you get? You get p plus q, and here p plus q, right? Okay? You do the experiment 2 times, okay? You have p squared, pq, qp, and q squared. And what about if you expand p plus q squared? What do you get? You get p squared plus q squared plus 2pq, right? Exactly the same as here, right? Okay? Get it? Follow me? Everyone follow me? Okay, so this is p plus 1 to 1's power, p plus q to 1's power, p plus q to 2's power, right? And now we do experiment 3 times. Okay, so of course you have success 3 heads. So that's p to 3's power. Okay? Sorry, it should be x equal to 2. Okay, it should be x equal to 2. X equal to 2, you have 3p p squared times q and 3q squared times p. And then there should be also 1. Okay, sorry. You know, quite a lot of mistakes. You know, next time I'm going to revise it. Okay, so let me put it down here. So first you have px equal 3, right? That is p to 3's power. Okay? And then px equal to 2, that is equal to 3p squared times q. Okay? And then here it should be 2, and then here it should be 1. Okay? px equal to 1 should be equal to 3 times p q squared. Okay? And then p x equals to 0, that is equal to q to 3's power. And then what you get? P plus q to 3's power. Okay? If you expand this, okay, if you expand this, you're going to get p to 3's power plus 3p squared q plus 3p q squared, and then plus q to 3's power. Okay? So basically, this is what you get if you have experiment, okay, if you do this kind of experiment for 3 times. Okay. Let us take a break. Discussion on binomial distribution. Okay, so the binomial distribution, basically it is like this, okay? P plus q to n's power, okay? So the coefficient of all the various terms corresponding to the probability, okay? So that's one of the most important reasons we say, you know, why this kind of distribution is called binomial distribution, because all the respective probability corresponding to the coefficient of the expansion of p plus q to n's power. Okay? So when you do the experiment for 1 time, so this is for you do the experiment 1 time. So of course, if you do the experiment only once, then the number of success can only be 1 and 0. Okay? So when it is equal to 1, the probability is equal to p. And when it is equal to 0, the probability is equal to q. And of course, you know that there should be a relationship between p and q. The relationship between p and q is p plus q is equal to 1. Okay? And now we have 2 times, we do the experiment twice. Okay? We do the experiment twice. So then the success is going to be 2. Okay? The highest number of success is going to be 2. And so if these are the success, so that, I mean, 2 times up, 2 times ahead, then it is equal to p squared. And when x is equal to 1, then you have pq and qp. When x is equal to 0, that means no success or failure. So it is q to 2's power, okay, q squared. And now we do the experiment 3 times. So p x equal to 3 to p to 3's power. And then here it should be 2, okay? Then 3p to 3p squared q. And this should be x equal to 1, 3q squared p. And x equal to 0, that means it is all failure, no success. So q to 3's power. Okay, let us move on, okay? So the probability is equal to the coefficient of the expansion of p plus q to n's power. That's the reason we say this kind of distribution is called binomial distribution. Okay, so this is a binomial form. Okay, when p is equal to 0.5, it is symmetric. Okay, when p is less than 0.5, it's skewed to the right, and p greater than 0.5 skewed to the left. And so now let me briefly explain to you what is skewed to the right, skewed to the left. Okay. Okay, so this kind of distribution we call skew to the right. Okay, this kind of distribution skew to the right. And this kind of distribution skew to the left. So this one, the slope, okay, so this is the slope. Slope is to the right. So this is skew to the right. The slope is to the left. So it is skew to the left. Okay, skew to the right, skew to the left. And what about this one? This one is called symmetric. Okay, this one is called symmetric because this side is actually the same as this side. Okay, this side is the same as this side. So this is called symmetric. Even this kind of distribution, we talk about, we just talk about uniform distribution, right? Uniform distribution, okay, it is like this. So what about this? The same thing. It is symmetric. Okay, it is symmetric because this side is the same as this side. Okay. Okay, question. And then we are going to calculate the mean and variance of binomial distribution. Okay? Okay, let's move on. So find the mean and variance for binomial distribution. So if you have experiment only one time, okay, experiment only one time, so px equal to 1 is equal to p, px equal to 0 is equal to 0, okay? So now, so if you have experiment, if you do the experiment only once, okay, if you do the experiment only once, that's what we call Bernoulli trial, okay? So what does that mean? You have x, okay, equal to 0 and 1. And px, it is equal to q and p, okay? So now you are required to calculate the mean and variance of Bernoulli trial. Bernoulli trial is, you have to do this kind of experiment only once, okay? So the same thing, you are going to get expectation of x, right? Expectation of x is equal to summation x times px, right? So that is equal to 0 times q plus 1 times p. So what is that? That is equal to p, right? Okay? And what about variance of x? Variance of x is equal to summation x squared times px minus mu x squared, right? So that is equal to 0 squared times q plus 1 squared times p minus p squared. Okay? So 0 times q, you get 0. And 1 squared times p, you get p. And minus p squared, right? So what you get? P and 1 minus p, right? Remember, what is the relationship between p and q? P plus q is equal to 1, right? So p times 1 minus p. So what is 1 minus p? 1 minus p is equal to q. So then it is equal to p times q. Okay? So the variance for a Bernoulli trial, okay, is expectation is equal to p and variance is equal to p q. Okay? Questions? So here is what we get. And now, after we finish Bernoulli trial, okay, Bernoulli trial, we have done that. That is the experiment for the only one time. And now we are dealing with binomial, right? Binomial, we have experiment n times. Okay, so here you do the experiment for n times. What does that mean? Okay, here you are dealing with this kind of variable, right? This variable actually consists of individual variables here. This is a Bernoulli trial once, another Bernoulli trial, another Bernoulli trial, another Bernoulli trial. You put all these things together, what is that? That is binomial experiment, okay, binomial trial. So then what you get? Expectation of x, because you have to do the experiment n times, not just one time. But if you look at it individually, that is one time, one time, one time, one time to n times. Okay? So what does that mean? This variable, this is for the binomial. Okay? For the binomial distribution, it is equal to n times of Bernoulli trial. Okay? N Bernoulli trial. So each trial is a random variable. And so this x is also a random variable, but it is a function of all these things put together, right? So we have learned this before. If you know w is equal to x plus y, what is the expectation of w? The expectation of w is expectation of x plus expectation of y, right? Okay? So then, what is the expectation of x? It should be expectation of x1, x2, etc. plus xn, right? So what is the expectation of this? It is equal to p. Expectation of this also equal to p. And then what about this one? Also equal to p. How many p do we have? We have np, right? We have np here, okay? Okay, the second one is about variance. Okay, the second one is about variance. It is here, okay? We have variance x1, x2 to xn, okay? But be careful here. We say if w is equal to ax plus by, okay, then what is variance of w? Variance of w should be equal to a squared vx plus b squared vy plus 2ab times covariance xy, okay? But remember, when we talk about binomial, right, each experiment is what? Is independent, right? So if each experiment is independent, what about covariance xy? Covariance xy would be equal to 0 because they are independent, right? So x1, x2 up to xn. So here you have covariance x1, x2, covariance x1, x3 up to covariance x1, xn, and then covariance x2, x1, x2, xn, etc. Okay, you have all these things. But what about those terms? Those terms are equal to 0. Okay? So then here what you get? You have variance of x is equal to variance x1, x2 plus xn is equal to vx1, vx2 up to vxn So how many do you have? You have n of them, right? And each one is equal to PQ here, okay? Each one is equal to PQ. So what you get? You get the variance equal to NPQ. Okay, questions? So now for Bernoulli trial, for binomial distribution, so in this case, for Bernoulli, okay, Bernoulli, okay, the mean is equal to P, the variance is equal to PQ, and binomial, the mean is equal to NP, and the variance is equal to NPQ. Okay? Any questions so far? Sorry. Okay, any questions so far? So whatever we talk about, as long as we talk about, random variable and distribution, probability distribution, we always need to talk about the mean, the variance. Okay, it is like that here. So for the Bernoulli trial, the mean is P, the variance PQ. For Bernoulli trial, for binomial, the mean is MP and the variance is MPQ. Okay, any questions? Okay, let's move on. So now we have a question. So a pack of poker, okay? How many cards does one pack of poker have? Mr. Fu. So how many cards does a pack of poker have? What is poker? The lady there, poker. Playing cards, playing cards. Anyway, so you have diamond, club, heart, spade, right? And each one has 13 cards, right? So there's a total of 52 cards. So that is poker. Have you played bridge? Play bridge? Right, yeah, bridge, okay. So if you play bridge, you use poker, right? And then you have heart, diamond, club, spade. You have four different kinds of cards, okay? And then for each one you have A, sometimes you call AC, right? And king, queen, whatever. Okay, so you have a whole lot of numbers there. Okay. So actually, when I mention this, you should know how many cards are there. 52. Okay, there are 52 cards. Okay, be careful. Drawing with replacement. Okay, drawing with replacement. So means if you take one out, you put it back again. So let us say you want to get heart. Okay, if you want to get heart, what is the probability for you to get heart? 1/4, so 1/4, right? If I don't put it back, what's the probability for me if I already take one out? Okay, if I already taken one out, and if I'm going to get a heart again, what's the probability? It should be 12/51, right? So the first one is 13/52. What about the second one? If it is without replacement. If it is without replacement, then the second one gonna be heart, okay, because I already taken one heart out. So there's only 12 hearts left, right? So the cards also one gone. So originally there are 52 cards, but now there are only 51. So take with replacement and without replacement, the answer is different. Okay. But here, what is that? With replacement. So that means each experiment is independent. Okay. And how many you want to take? You want to take 5. Okay. You want to take 5. So what's the probability of getting exactly 3 hearts? Okay. That's the first question. What's the probability of getting exactly 3 hearts. But remember, how many do you get? You get 5. Okay, you get 5 out of it. But here you are only concerned how many gonna be red? Hearts. 3. Okay, 3. The probability of getting at most 3 hearts. What means at most? The gentleman in blue t-shirt. What means at most? So you are drawing 5 cards, right? You are going to draw 5 cards. What means at most 3 hearts? What are the possible values? 3, 2, 1, 0. Okay, because that's at most 3. What about at least 3? At least. If we say at least 3, that means 3, 4, 5. Okay, so that's at least. At most, so that's the most you can have. So the highest number is 3. But if anything that is less than 3, that's fine too, because you say at most. But what about exactly? Exactly, you have to have 3 and exactly 3. Okay, at most 3, you can have 0, 1, 2, 3. At least 3, 3, 4, 5. Okay, at least means greater than or equal to 3. At most means less than or equal to 3. Okay, questions? Questions? Okay, so now let us check the answer. These questions will be in the second midterm. Okay. Okay, let's look at this. Exactly 3. Okay, so this is combination. C, 5, 3. This is what we call combination. So you have 5 cards. Okay, you have a total of 5 cards. You only want to make sure that you have 3 hearts. Okay, do you care about the order? You know, the first one is red or the second one is red? No, you don't. You only want to make sure that you have 3 hearts. So here you use combination. Suppose you care about the order, okay, which one is first, which one is second, then you use permutation. Okay, in that case you use permutation, but here you use combination. Okay, because you talk about exactly 3. Okay, what about the probability to get 1 heart? Okay, the gentleman there. What's the probability you get 1 heart if you draw from a pack of poker? 1/4, right? So 1/4. And how many hearts? 3. Okay, so C combination 5, 3, and then you get, this is the probability. Okay, here that's the probability of getting heart. So how many do you get? You get 3. Okay, you get 3 hearts, so that's 1/4, so 1/4 to 3's power. If you get 3 hearts, what does that mean? The other 2 are not hearts, right? The other 2 are not hearts. What's the probability not getting hearts? It should be 3/4, okay? 3/4. So then that is to 2's power, okay? To 2's power. Okay, the second item, because now we are talking about at most 3, okay? At most 3, that means less than or equal to 3. So what does that mean? That including x equal to 0, x equal to 1, 2, and 3. So here, what you have? 0 to 3, right? 0 to 3. And of course, you are not sure what's the number, right? So here you have, it can be 1, can be 0, can be 2, can be 3. So here you use x here. Okay, here you use x. The same thing, here you use x. Okay? And what about here? Because for all the cards you get, you either get heart. And what's the number of heart? The number of heart is x. Then what is the number of not hearts? It is 5 minus x. Okay? So here you have x, and here you have 5 minus x. Okay? Okay, then the third question, we say you want to get at least 3 hearts. Okay, at least 3 hearts. The same thing. The only difference is that Now it is 3, 4, 5. Okay? So here you have x equal to 3 to 5. And here you have x, here you have x. And what about here? 5 minus x. Okay. The reason you use x is because you are not sure how many hearts you get, right? It can be 3, can be 4, can be 5. And then if you get 5 hearts, what about the other cars? Then if that's none, 0. 5 minus 5, that's going to be 0. Okay, so here you have to use variable here. Okay, questions? Okay, move on. So the probability of defective is 0.3 for a product. And you're going to choose randomly 20 items. What is the probability of exactly 8 defective, at least 8 defective, at most 8 defective? So, Mr. Ren, the first one. Okay, what's the probability, okay, for you to get exactly 8 defective items? You should follow this kind of example. Okay, tell me what's going on there. Follow this kind of example. But here we have probability for defective is 0.3. And how many do you choose? You choose 20 out of it. Okay, you choose 20 out of it. And now you want to make sure that what's the probability you get 20 out of it? What's the probability that 8 of them are defective? Okay, Mr. Ren. The example is here. Okay, follow the example. The defective rate is 0.3. Okay, and you get 20 out of it. Okay, you choose 20, and the probability, you are looking at exactly 8 items. Okay, exactly 8 items are defective. Okay, Mr. Ren. Don't worry, you can speak Mandarin. Sure. So look at this. This is the example, right? Okay. So combination 20 and 8, right? Among 20, there are total of 20, and you want to get out of it 8. Okay, number 8. And that is 0.3 to 8's power. And 0.7 to 12's power. Okay? Okay. What about the second question? Miss Lai. Second question. At least 8. Okay? At least 8. And the example is here. Okay? Okay, Miss Lai. Exactly, okay? So actually the answer is here, right? So because it's at least 8, okay, at least 8, so you have summation x from from A to 20, right? And combination 20x. And 0.3 to x power, 0.7 to 20 minus x power, okay? Okay, the third question, okay, the girl in pink coat. So what should be the answer for the third question? Okay, so because we are talking about x less than or equal to 8, right? And summation x from 0 to, sorry, it should be 8. Another typo, okay? From x from 0 to 8, and combination, okay, combination 20 and x, 0.3 to x power, and 0.7 to 20 minus x power, okay? Okay, any question? Sorry, there's another typo here, okay? It should be 0 to 8, okay? 0 to 8, not 0 to 20, because we are talking about x less than or equal to 8. Okay. And now we are going to talk about, just briefly, what is binomial. Multinomial, okay. The binomial, we only have two kinds of cases, okay. One success, one failure. But you generally know there are a lot of different cases, right? So, case A, case B, case C, for example, say, if we talk about poker, at least you have diamond, club, spade, and what's the other? Diamond, club, spade, and heart. So you have four different types, okay? You have 4 different types. So in this case, actually, if you're going to talk about binomial, that's kind of problematic because you have 4 different types. So multinomial, that is about if there are cases that you can divide into a lot of different cases, okay? And so in this case, poker, okay? And as a matter of fact, there are a lot of different cases. For example, for the distribution of the score, we are talking about you have people above 90, okay, between 80 and 90, again below 60, etc. You have several different kind of possibility, okay? And for each different kind of possibility, of course, you want to talk about what's the probability for each case. So if you have many different kinds of outcomes, okay, if you have many different kinds of outcomes, for binomial, you only have 2 different kinds of outcomes, success, failure. But if you want to deal many different kinds of outcomes, then you use to multinomial, okay? Okay, and of course the same thing, you have probability there. You're going to calculate the mean, calculate the variance, okay? But in this case, we don't deal with it, okay? Questions? Okay, here, this is one example, okay? So let us forget about this one. Hypergeometric, okay? Hypergeometric, what's the difference with this one and the other one is actually here. Drawing without replacement. Okay, so when we talk about binomial, it is drawing with replacement. It is drawing without replacement when it is hypergeometric. Okay, so let me repeat this again. If you only have 2 different outcomes, drawing with replacement, that is binomial distribution. Drawing without replacement, that is hypergeometric. And the same thing, if you look at this form, it's quite complicated, right? And for this complicated form, you also are required to calculate, okay, the mean, the variance, and of course that's even more difficult. Let's forget about it, okay? So basically you don't have to deal with it. If you want to calculate the mean and the variance in this case, you have to learn combination, okay, combination mathematics. So there is a there's a discipline of mathematics dealing specifically with combination. Okay, so this is kind of difficult. So anyway, we don't want to get into too much detail of it. So if any kind of experiment, you have only 2 possibilities. Drawing with replacement, that is binomial. Drawing without replacement, that is hypergeometric. Okay. Okay, Poisson. I believe we talked about this before. It is a weighting line. Okay, so if you weigh in line, okay, there is a certain kind of phenomenon, and that kind of distribution is Poisson distribution. Okay, so for example, operator want to handle phone call, right? An operator handling phone call, the same thing, use Poisson distribution. Okay, I think that's about it. So we're gonna meet again next week.